Today we're going to look at selected problems from Chapter 4 and discuss how to solve them, give you some hints in case you had some trouble. We're talking about solutions and we're talking about concentrations of ions in solution. So it's always helpful to draw a picture of this. I'll draw a quick picture of this beaker right here with the calcium nitrate. Whenever you have calcium nitrate, it does dissolve in water because of nitrochlor, you know that. And here's, you're going to have one calcium ion and then you're going to have two nitrate ions. So you're always going to have twice as much nitrate as calcium. If you know the moles and the milliliters of solution, you can find the concentration, which is molarity. So molarity equals moles of solute, which is the calcium nitrate, over liters of solution. They told you that you have 0.1 moles of this, and you have to change this into liters, the milliliters, so it's 0.1. So this comes out to be 1 molar. Now this is the molarity of the CaNO3 parentheses 2. So in order to understand this, let's talk about bikes real quickly. So we'll draw a quick sketch of a bicycle. This is not good, I know. All right, just go with me on this. So there's a bicycle. Now, if I said, how many seats do you have on a bike? If you had 10 bikes, you would have 10 seats. Okay, so if you had 10 bikes, you'd have 10 seats. If I said how many tires would you have, you'd have 20 seats, 20 tires, because you have twice as many. Now, it makes sense to you. You wouldn't say, well, how could 10 things be 10 plus 20, which is 30 things? How could that be? Well, it's because the tires and the seat are just part of the bike. The bike is way bigger than tires and seats. So it's kind of the same thing with calcium and nitrate. You have 1 calcium and 2 nitrates in this formula. If you have 1 molar concentration, what happens is you have 1 molar of this and 2 molar of that, because it's 2 pieces of nitrate and 1 piece of calcium. So the concentration of calcium, that means concentration, the square bracket, is 1 molar. And the concentration of the nitrate is going to be twice as much, which in this case is 2 molar. So that should help you with all of number 23. 25 is a very similar problem where you have to find the concentration of chloride in each of these solutions. So once again, if you look at AlCl3, you could see that that solution will be 1 Al plus 3 and Cl minus is times 3. So again, if you set up your molarity equals moles over liters, you know that the molarity is 0.3 and the volume is 0.1. So you could find the moles of this, which is going to be 0.0300 moles of, oops, I'm sorry, that should say Cl minus, AlCl3. All right, this isn't going to let me erase, so I'll just fix it. AlCl3. Now, problem 25 is asking for which has the largest number of moles. So I'm sorry, I should have said moles here, not concentration. Highest number of moles. So there's my moles of AlCl3, but I'm not really done yet, because that just tells me the AlCl3. It doesn't tell me the Cl minus. So the Cl minus is going to be times 3. Because we have 3 Cl minuses in every formula. So that's going to equal 0.09 moles of Cl minus. So you need to do that with each of the solutions and then find out which one has the highest number of moles of Cl minus. Okay, number 29 is asking how do you prepare a solution. There are 2 ways to prepare a solution. One is from a solid and one is from a stock solution. So here's the solid way. So you just go molarity equals moles over liters. You know the molarity right here is 0.250. You know the liters is 2. So you solve for the moles. You could do that in your head, which is going to be 0.5. Okay, so you think you're done, but you're not quite done because it says how would you prepare 2 liters of this. So how do you prepare it? Well, you can't measure out moles. You have to measure out grams. So you're going to have to convert that. So moles on the bottom, grams on top. NaOH weighs 40 grams per mole. And then when you do that math, you're going to get an answer of 20 grams of NaOH. So the final answer is take 20 grams of NaOH and dissolve in 2 liters of solution. Don't say water, because the solution includes that NaOH. Now, just for the record, how you would do this in real life is you would get what's called a volumetric flask. A volumetric flask is a flask that has a very long neck, and that mark right there you'd have to get for the specific volume you want. So in this case, it would be a 2-liter volumetric flask. You would put your sodium hydroxide right in here. Okay, they're solid. And then you would fill up the water all the way to the mark. So the answer would be dissolve 20 grams of NaOH in 2 liters of solution using a volumetric flask. Okay, now we'll go to the next page. In part B, you're using a stock solution. So let's say you have a very concentrated solution of NaOH, and it's in this jar, let's say, this container, and it's very concentrated. Okay, let's say this is a 1 molar. I'm sorry. Oh yeah, you want to make 0.25 molar. So this is the stock solution, and you want to make this solution. And in part B, you're trying to make still the same volume as before, 30, which is 29. Sorry, 2 liters. You want to make 2 liters. So you want to make 2 liters of this. So this is like we did in class. You want to take this and then make a 2-liter container, and it's going to be less concentrated. So this is going to be M1, V1, M2, V2. So you're going to use M1, V1 equals M2, V2. This is for dilution from a stock solution. Your first molarity is 1 molar. Your second molarity is 0.25 molar. You want to make 2 liters of this, and you want to know how many liters of this are you going to need. So when you do the math, you're going to get an answer of 0.5 liters. So what does that mean? Because you're not really done. Again, you're going to need a volumetric flask. So let's draw a quick picture of this. You're going to need a 2-liter volumetric flask that has a mark at the exact 2-liter. And what you're going to do is you're going to take your 0.5 liters of your concentrated. So this is going to be right there from that. And then you're going to add water until it dilutes to a total volume of 2 liters. Number 30 is very similar to this problem. And then lastly, 33 is kind of like a more complicated version of this type of problem, where you have this stock solution that you're making of this material right here, and you have 10 milligrams of it, and you're dissolving it in 500 milliliters of solution, and then you're taking 100 microliters of that, which is the stock, and you're going to dilute it into this. So the stock solution right here is the original. So let's do the stock first. The stock solution is molarity equals moles over liters. So you need your moles of solute, liters of solution. They told you that the liters of solution is 500 milliliters, so 0.500 liters. And you need to get the molar mass of this. So that's going to be your 10 milligrams of the C20H29FO3. Converting this into moles, you want to get rid of milligrams. So we put milligrams down here and grams up here. There are 1,000 milligrams per 1 gram. And then you want to get rid of grams and go to moles. And this weighs 336 grams per mole. So it's going to tell you the moles, which is 2.98 times 10 to the minus fifth. That's how many moles of this steroid that you have. So this moles goes up here, 2.98, 10 to the minus fifth. So all you're doing is getting the concentration of your stock solution right now. Okay, that's your stock solution. So when you get that concentration, it's 2.98, 10 to the minus fifth divided by 0.5 is 5.94 times 10 to the minus fifth molar. So that's the concentration of the stock. That's part one of the problem. Now we got to do part two, where we take that and we dilute it into a different amount. Okay, so we take some of this stock solution and then we dilute it with some water. So that's going to be an M1, V1, M2, V2. So I'll put that over here. M1, V1 equals M2, V2. So we said that the final volume is 100 milliliters. I'm going to put that into 0.1 liters. And then the first molarity is what we learned before. So this is the original stock solution, which is 5.94 times 10 to the minus fifth. We took out 100 microliters of that. That's what that little symbol in the book is. This is micro, mu. It's called mu. Looks like a U. It's actually an M in script, sort of. So this is going to be 100.0 microliters, but you have to get rid of microliters and go to liters. So there are 1 million microliters in 1 liter. The reason I did liters here is to match this liters right here. You could have done, whoops, you could have done any kind of volume that you wanted. Let's see if this erases. All right, I don't know why it's not letting me erase. Anyway, so now you're just going to solve for that molarity, do all your math. You should get an answer of 5.94 times 10 to the minus eighth molar. That is your final answer for this problem. So very briefly, let's review one more time what happened. It's complicated. We made a stock solution first. They gave me all weird units. So the mass in here was in milligrams. I had to change it into moles, which is this, divided by the total volume of the stock solution, which was this answer, is the molarity. Now I take this stock solution, dilute some of it into another container. So this is the original molarity. This is how much I took, which was in microliters, which was kind of a pain of this. And then I knew my final volume was going to be this, and I just did the algebra to find the final concentration.